The corrosion groups are fairly straightforward, and they pretty much do exactly what you would expect. It is a runtime load pattern. So we build our model, we load our model in its original state. We can create as many load cases as we want. And with regards to how the corrosion is treated, it's simply an additional load pattern that we add on to an existing load condition. To create it, we just come into whichever load condition that we want to run in a corroded state. And we may want to make a new one. If we want a separate uncorroded versus corroded version, we could simply come in here, create a new load case, and we'll copy, let's say this one, and make it corroded. And we can have multiple types of corrosion. Since it's just a load pattern, we can have one condition where we're doing tank corrosions, one where we're doing deck plate corrosions, one where we're doing all of them, as well as different levels of corrosion. So you can have as many of these as different load cases as you want. And if we just click the corrosion tab, it'll allow us to add, I guess, corrosion groups, which, as you can see, we don't have any available yet. So the first thing we have to do is come in and start creating some corrosion groups. And we've created groups before. It's just a different type of group. Create a new one here, and we've got a couple options for how to start adding the elements. Now, full strake, full compound is back for the original coarse mesh model that's using those strake elements. Doesn't really affect us for this model where they're all quads and tris and beams, but that is available. Whether this is toggled or not won't affect us at this point. There is an option for adding a whole module all at once. And if you wanted to corrode the entire ship, a quick way to add it would be by module. And when you do this, it's slightly different in terms of assigning your corrosion. Now you'll see we've got all of these different items in the table for our corrosion elements here, but when we add a whole module, it asks us for the information in a separate dialog, but it's all the same information that's available down in this dialog. The corrosion side, which is listed right here, the corrosion method listed here, and the amount of corrosion for the plate, web, and flange, which will be these three columns. We can also use by box, where we just drag a box and select everything in that window. Or what's probably a little more accurate if you have specific details, like what I'm going to do here is I'm going to corrode just this one tank. We're going to say this tank is carrying some fairly corrosive chemicals or something. And you can see there's one little mistake I made on this one where those stiffeners are on the inside of the tank. On the other faces, the stiffeners are on the outside. So we can fix that quickly with a general group. There we go. Add by seed, add attached beams. Actually, I'm going to remove that hull quad so we don't grab any of the stiffeners on the hull. And I'll add attached beams and then flip the normal of the beams. And you can see now they're on the outside of the tank. Not that that would matter. Whether the stiffeners are on the inside or the outside, the corrosion is applied independently. You tell it whether or not a stiffener or plate has corrosion and how much and where. It can be applied separately for plate, the web, and the flange, and it can be different for every element in the model or every element in a given group. So to grab this tank, we'll create a corrosion group, and let's call this one tank, because we're only going to make one of them. And I will grab, there we go. That's what I was trying to do. So we grab a face from each side of the tank and one from the bottom, and then we'll come up to the opposite corner back here, and we'll grab one from the top and the shell and the aft bulkhead. And I'll grab all of these and say add by seed advanced, and I will pick that corner, which is on the widest part of the tank up at the top, and the opposite corner will be on the bottom on the nearest corner, and we'll add. So now we've got everything in the tank, and we will also add the attached beams. Now, in terms of what I want to corrode, I only want to corrode the beams that are inside the tank, exposed to whatever this chemical is. So I'll create a group with everything in there because it's often a little easier to delete. And we'll come in and do something very similar. Grab those two sides in the bottom and this aft side, add by seed, add the attached beams, and then sort by type and keep all of the beam elements in there. And we will remove all the quads and tris and return them to the model, or return them to the group rather, and then delete the rest of the contents, which are all those beams. So now we have just all the plating for the tank and the shell stiffener and frames and the deck stiffener and frames, which are inside. So we'll bring our corrosion group back up, and now we'll assign some corrosion. Now the side gives you three options: the stiffener side, the plate side, or both. We'll just use the stiffener side here as the default since it's the inside of the tank. And when it has both there, I tried this earlier, and both, I guess, does not double the corrosion on the plating. It simply, I think, tells it where to remove material for purposes of, I assume, computing the neutral axis for the stiffener plate combination and section modulus. That's what I assume, since it's not doubling the corrosion. I believe that's what it's used for. The other option is the method, and you can do this by the percent corroded, in which case we would put percentages in here in whole numbers. So 50% would actually be 50, not 0.5. But we can also put in net corroded, and when we switch to either the net corroded or the other option is net remaining, the units will populate, and right now we're working in meters. So if we wanted to, say, put on 5 millimeters of corrosion, we would have 0.05, and then for the web, we'll put 0.03 and 0.03 for the flange. Take quite a while to do that individually for each of these. So there's a quick option where you can simply select one of them, and when you right click, in addition to the normal options for adding elements to the dialog, there's also one at the bottom here, which is assign same value as the highlighted row 1. So we only have one row highlighted, so it'll be that item, and when we click it, it'll get applied to everything in the entire group. Now you can see where it's a beam element, the plate box is grayed out, but since it got copied to everything, it is populated with a dimension there. Once we modify this, and if we were to close this dialog and reopen it, you'll see those beam values get removed again. If we were to copy it again, they'll get filled in, but they don't mean anything. They'll get removed the next time the dialog is opened. The other thing we can do here, and you'll notice that when it gets copied, it not only copies these dimensions, it'll copy everything. Well, not everything, I take that back. It does not change the side. It does change the method along with all of the values, not just the one that may have been changed. But I guess it does not change the side. That has to be changed manually. Now, the other thing is, if you knew where these quads were in here, or where the beams were, and you wanted to change them specifically, often it's easier just to create a second corrosion group, because you can have as many of these groups as you want, rather than if you want to apply a non-uniform corrosion. But if you knew where all of the quads were for the top, you could select them individually in here and change their corrosion values. And if you had them all grouped together, and let's say they had ID numbers that were sequential, we could simply sort by ID number, and let's say it was this first group here were the ones we wanted to change, and we wanted to, because it's on top and doesn't get exposed as much, we'll only put 3 millimeters of corrosion on the plate there. What we can do is we make the one with the value that we want as the target as the first row, row 1 in the selection group, and we select some number of items. If we have a group selected, when we say assign same value as the highlighted row 1, whatever is in the first row of the highlighted group, that'll get propagated to all of the elements in that selection set. So if I were to change that to percent corroded and 50%, 50%, 50%. Copy them down here, and all of those will get changed, but the rest of the group remains unaffected. And if I want to put them back, I can simply click on one row here, use the assign same value, and now they're all the same again. So that's the, I guess, how you would go about setting corrosion values. So we'll go ahead and modify this, and we'll go back and create another corrosion group. And let's create a corrosion group for all of the wetted surface in the hull. Now, we could manually come in here, create a corrosion group, and say, wettable elements, and come in, grab one, add the seed, and then fill in any missing elements from here. But we know there's an easy way of creating a group of wettable elements with just the group extract wettable elements. Or let's say we wanted wetted elements for, just what was going to be typically below the water line. If we extract wetted elements, that's basically where our water line is and all the elements below it. Maybe we just want to apply corrosion to those. But for purposes of this, we're going to use all wettable elements. So we create that group, but it's a general group. It's not a corrosion group. But we can change it very easily by just moving it into the corrosion group. And now it's a corrosion group. If we come in and edit that, you can see we have all of those additional options available for the plate and web corrosion. Now, there are no beams, none of the attached beams are on this, but if we're saying it's from the seawater causing the corrosion, then maybe we don't want the beams to be on here. If we did, we could simply come in here and say add by attached beams, and it would pull in all of our frames and shell stiffeners. But for purposes of what we're going to show here, we're just going to leave the plates there. And because like in way of the tank, we've already corroded the beams on the inside of that tank that's up against the shell in this region. But we'll come in and we'll add some net corrosion here. And this will just be 2 millimeters of plate corrosion. Now we could define web and flange corrosion in here. It would accept it, but it's meaningless since we only have quads. Since it's in a different group, we can probably reuse the same name, but I'm not positive of that. So we're going to call this wettable corrosion. And good measure, let's create one more with some very serious corrosion on the deck. So near midships here, we're going to create one called deck patch. And we'll just add one element. We'll do add by seed advanced, and let's make this patch from, there's a frame there, come down and we'll go outside that girder 5 meters off, and we'll corrode it to that area. We'll go ahead and add attached beams, but this time we'll use the net remaining, and we're going to apply some very serious corrosion here, and we'll only leave 5 millimeters left on the plate, like that 0.05, 3, and 3 for the flange. Copy that. You may have noticed the stiffener was only filled in on the first one, but if we come in and view the wettable corrosion, oh, none. I haven't seen that before. Actually, I didn't think that was an option. It doesn't even present an option for changing that. What I mainly wanted to show, having that wettable element group, was whether or not you can have a cumulative effect of corrosion. So basically, we have the shell portion of this tank defined in 2 separate corrosion groups. And that's perfectly fine, that you can have an element in multiple corrosion groups and everything. The question is, can you have both of those corrosion groups in the same load condition? And that's what I wanted to test here. Let's see what happens. So we come into our load condition here, and we'll just apply this to the first one. And we'll enable corrosion, go to the corrosion tab, and we'll start adding our groups. So we've got the deck patch available, so we can add that one. We'll come in and we'll add the tank. And then we'll come in and we'll add the wettable corrosion area. And we'll talk about this percentage of remaining thickness in a minute. By default, it's 100%. And basically what it does is we have our uncorroded model as our baseline. Then we apply these corrosion groups to modify our baseline model for this particular load case. And what it'll do is wherever we've assigned corrosion, whether it is the net remaining, the net corroded, or the percentage remaining, it will reduce the plate, web, and flange thicknesses appropriately. Leave us with a new thickness, which is what it uses to run the model. And when that's at 100%, basically that's what you are left with. It's the original scantlings minus the corrosion, and you're left with that thickness. Well, you can change that rather than reassigning the corrosion levels or changing your original scantlings. And remember, changing your original scantlings is going to change all of your load conditions if you have lots of other ones defined, because let's say you had a corroded element and it started to fail because you were required to corrode that by 3 millimeters, and now it fails. And you want to know how much thicker do I need to make that original? Well, you can scale this up or down. So maybe it was too thick and you want to reduce it further, but not redefine all of your corrosion groups. You can, this is a multiplier of whatever that new corroded scantling is. So let's say we had 15 millimeters as the original plate thickness and we corroded it by 5. So now we're down to 10. If we leave this at 100, we keep 10. If we change this to 75%, it'll drop to 7.5 millimeters. Or if we make this 150%, it'll go back up to 15, the original thickness. So you could play some games with this to either increase your thickness to say like 110% to see if you still get the failures, and that'll give you a good ballpark of what your required thickness is going to be. Or you can reduce it further if you want to see if you can save some additional weight. Maybe you take it down to 90 or 80% and see if you can either have a larger margin for how much corrosion you're allowed, or you can reduce the original scantlings. Let's look at what happens when we add all of these corrosion groups. Now, when I say modify to apply these, I get an error. Well, not really an error, I get a question. Maestro has detected that I have duplicate elements between these corrosion groups. So I have basically corrosion on some of these elements defined in 2 of the groups. Now, it's not a problem to have them in 2 groups because maybe the deck patch goes in one load condition, the tank goes in another, and the wettable corrosion goes in a third. So they'll never overlap. They're never corroded at the same time. But here, I'm telling it to corrode both the tank and the wetted surface at the same time. And that outer skin of the tank is also part of the wettable corrosion. Now, if I say no, it will fail to create the corrosion load case on there. So I'll have to come in, go into corrosion group, and I'll add all of them back in here. Now they're in a different order. It's tank, then the order of they were created, 1, 2, 3. So we have tank, wettable surface, then the deck patch. And if I say modify, now it wants to remove the duplicates from the corrosion wettable. If I change the sorting, it won't resort. I was hoping I might be able to rearrange them. Basically, when it sees a duplicate, it is going to subtract it from whatever group was added later. So right now, if I say yes, subtract those duplicate elements, it's going to subtract them from the wettable corrosion because it found them in the tank first. So those it's going to keep. When it sees a repeat in a subsequent group, those are the ones that'll get removed. So if I wanted it to remove the corrosion from the tank group for those duplicates, I could have added the wettable corrosion first and the tank second, and then it would have said clicking yes will remove it from whichever group comes second. As it is now, I think the tank corrosion is more important, so I'm going to say yes, go ahead and remove them from the wettable corrosion. So now it accepts it. It created the group. I have my corrosion group defined, but one thing to note is that it modified that group, and not just for this load condition, because it is a group and can be used in other load cases. The groups are sort of separate entities. So the corrosion groups can be added to different load cases as needed. But if I were to display these again, let's do assign color. So those are my corrosion groups. Now you expected this one to overlap, but if I hide the tank group, or actually let's just view the wettable group, it removed those duplicate elements, but it didn't just remove them from that particular loading condition, it modified my actual corrosion group. So if I had a different load condition where I did want to corrode all of the wettable elements on the hull, I'd need to make a second group that restored that patch area, because it's going to be missing from this group, from this version of the group. So if there are areas where you may want it used in more than one group, you may have to divide those out. But you'll get this warning, when Maestro detects that an element is used in more than one group in a single load condition. But I just wanted you to be aware that when that happens, if you see that dialog and it says, do you want to remove these from the group, it is modifying the original corrosion group, not just this load condition instance. Now we don't even need the wettable corrosion group, so if I go ahead and delete it, and I can delete the entire group, when I come back into my loading condition and I check my corrosion groups, it's been removed here. It no longer exists.